Here, we're given a function of f of t, then we will transform it to a Laplace transform of f of s. These are the set of Laplace transform that are able to get by integration with the limits of 0 to infinity. And now, we have given a function of f of t, e raised to negative 2t plus sine 4t minus t raised to 6 minus hyperbolic cosine 5t. By Laplace transform, we will be able to get the Laplace transform by the previous formulas. First, we will get their Laplace transform one by one, so we can write it separately in the manner of the symbol of Laplace of e raised to negative 2t sine 4t t raised to 6 hyperbolic cosine 5t, and we know that e raised to negative 2t is equals to 1 over s plus 2. Then for sine 4t is equals to 4 over s raised to 2 plus 4 raised to 2. Then t for t raised to 6 is equals to 6 factorial over s raised to 6 plus 1. Then for hyperbolic cosine 5t is equals to s over s raised to 2 minus 5 raised to 2. And we have the final answer here. The final answer here is 1 over s plus 2 plus 4 over s raised to 2 plus 6 plus 16 minus 240 over s raised to 7. And lastly, minus s over s raised to 2 minus 25. Other method of Laplace transform is the inverse Laplace transform. From the word itself, inverse means we need just to take back what we get in the Laplace transform to its original equation. By doing this, you need to familiarize the set of formulas from the Laplace transform to proceed with this method. From the example earlier, we will try to get the inverse Laplace transform of our final answer. First, we need to write the symbol of inverse Laplace, which it has to give negative in the upper right side of it. Then we are given a function of s, which our final answer earlier is equals to function of t. So we need to get the original form of our given function, and now the same process we will need just to take the inverse Laplace one by one. The inverse Laplace of 1 over s plus 2, just looking at the set of formulas, we know that it is in exponential form, and when it is in positive, we will change the sign and it will become e raised to negative 2t. After that, proceed to the next one, which is the inverse Laplace of 4 over s over 2 plus 16. Again, just look for the pattern on our table or set of formulas. By observing it, the given as a s raised to 2 and it's in addition, so it simply has an a which is equals to 4 and a raised to 2 which is equal to 16. So it is just an sine 80, and our e is 4. Therefore, our final answer is sine 4t. Then the next one is 240 over s raised to 7. Again, just look on the table and observe. Here, we notice that it has a power that raised to higher than 2, and it only have s in the denominator, and in numerator, it looked like we got a factorial of 6, and this form is equals in t raised to n, which in equals to the power of it, and we know that it is equals to n factorial over s raised to n plus 1. So by inverse Laplace, we now use subtraction to be able to get the n of the given function. Therefore, n is equals to 7 minus 1 is equals to 6. So simply, it is equals to t raised to 6. And last is the s over s raised to 2 minus 25. Observe again and look the table here. We have a denominator of s over 2 and it's a subtraction. So basically, we know it is hyperbolic with a equals 5 and a numerator of s. So simply, it is equals to hyperbolic cosine 80, which is hyperbolic cosine 5t. Then just write it again and combine them. The final answer, it will be e raised to negative 2t plus sine 4t minus s raised to 6 minus hyperbolic cosine 5t. And by logging from the original function we have previously answered in Laplace transform, they are just equals, meaning the inverse Laplace can use to check if we're correct in performing Laplace transform. That's all. Thank you.